video I will explain how NeuroCellSim uses neural networks as liquid state machines to think and how to implement a learning process. I will also talk about the option of using spiking neural networks, more similar in their way of working to biological ones. In this new version, the option to limit the distance of vision has been included, so that the cells will only see the nearest food that is within their vision range. The mathematical basis for representing neural networks for NeuroCellSim is a two-dimensional matrix on whose axis all neurons are represented. Each of the entries in the matrix contains the value of some synaptic wake, positive or negative if there is a connection, and equal to 0 if there isn't any. However, in order to better simulate biological neural networks, a series of general restrictions must be imposed on the neuronal matrices and the positions where connections can be formed. All NeuroCellSim neural matrices share the same three restrictions. There cannot be connections in any of the four red areas of the neural matrix. These restrictions ban incoming connections at input neurons, outgoing connections at output neurons, any type of connection between input and output neurons, and self-connections at any neuron. All rows and columns, except those that fall entirely in the red areas, must contain at least one connection. That is, all input neurons must have at least one outgoing connection, all output neurons must have at least one incoming connection, and all hidden neurons must have at least one of both. There cannot be two symmetrical connections on V1 and V2 at the same time. That is, there cannot be two neurons sharing an incoming and an outgoing connection. In this way, loops cannot be formed between two neurons, although they can be formed from three. More will be said about loops and their possible value in future videos. During the thought process, NeuroCellSim uses the neuronal matrix and the neuronal states to update it for each neuron of each cell at every iteration of the simulation, and the cell updates its position depending on its output. When implementing a learning process, it is essential to provide the neural network with the ability to change, transform, and adapt over time. Indeed, the ability to learn is strongly linked to that of changing preconceptions and generating new ideas. In NeuroCellSim, there are 3 degrees of freedom or learning access through which neural networks can be modified. Waste learning, strengthening or weakening connections. Each time they are used, the connections are reinforced by slightly increasing the absolute value of the wake. If the connection is not used, the absolute value of the wake is very slightly decreased. Over time, the more used connections become the dominant transmitting information, while the less used become weaker. Synaptic learning, creating or destroying neural connections. When the absolute value of the neuronal state falls below the lower electrical limit parameter, a new incoming connection is created to that neuron. Otherwise, if the absolute value of the neuronal state rises above the upper electrical limit parameter, an incoming connection to that neuron is eliminated. That is, if the neuron state is near north of 0, the neuron gets a new incoming connection. If the neuron state is high enough, the neuron loses an incoming connection. Neural learning, creating or destroying neurons. When the total output of a cell exceeds the threshold of its number of hidden neurons squared, a new neuron is created. When the total output of the cell falls below a certain limit, a random neuron is destroyed. The neurons that are created are also subject to the 3 restrictions, so each new neuron will have at least one incoming and one outgoing connections. That is, if the neuron state is high enough, the neural network gets a new neuron with random connections. If the total output is near north of 0, a random neuron is destroyed, along with its connections. In this version, along with the learning process, an option has also been implemented so that neural networks can work as spiky neural networks, more similar to biological ones. In other words, each neuron has an associated electrical potential that allows or inhibits the outgoing connections impulses. Neural electrical potential and its dynamics depend, in turn, on the number of incoming connections. In the case of using spiky neural networks, a decrease in their performance will be noticed. They tend to move more slowly, they have fewer outputs per second, and it is advisable to give them a longer life if they are mortal to avoid more simulations ending up in extinction. A possible explanation for this different performance could be due to the simplicity of the environment. In NeuroCellSim, the only inputs that neural networks receive are the distance to the closest food in 2 coordinates. It is likely that the use of an electrical potential does not imply any advantage for that environment. It could be useful or not in a more complex environment. Although images will be used in the following videos without the spiky neural networks options activated, the implementation of this alternative enables 2 new features. The information contained in the electrical potential will be used to decide which connections are used and which are not in the process of learning weights. In the graphical representation of the neural network of the next version, the connections used will flash as if they were a spiky neural network, even if they aren't. Finally, although these points will not be resolved through the development of NeuroCellSim, it would be useful to question the arbitrariness of the limits used in the learning processes. In weights learning, the limits depend on the potential, which in turn depends on the number of incoming connections. In the case of synaptic learning, the limits are set by the user. In neuronal learning, the upper limits depend on the square of hiding neurons and the lower limit is proportional to the number of hiding neurons. In the next video I will talk about the types of reproduction that exist in NeuroCellSim and how they allow to create new neural networks from previous ones.